Hi everyone, welcome to class 4. Today's quote: always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. This quote I've seen in a lot of famous programming quote sites, but it's really just from a random forum, so if we check this out. The link is a little bit messed up. Should be a hash there. There's random guy, John F. Woods. They're talking about programming and using some obscure operator in 1991. Quote's very appropriate for today, so we included it. It's a good one. It's a good code to live by when you're programming. Alright, so today's 20s. We're going to be working on components. So these are pieces of code in React. We're going to work on CSS layouts and coding style. So jumping right into components. Components are part of the React framework. They're essentially like the smallest pieces of code you should have in the framework, and they are reusable. They're building blocks. You can create them once and use them multiple times, and they have JSX in them usually. Not only that, but they can be used in JSX. Now, React has a way to automatically translate them to HTML. They're not, when you're working with JSX, it's not actually HTML you're working with until it gets translated to HTML. It's a JavaScript object first. So first, let's start with how React actually renders these components. So in React, we have what are known as elements, and those are the simplest React representations of HTML elements, and they're JavaScript objects. Now, React manages, when React goes to render to a page, you actually tell it which HTML element to render to. And it's clear to explain that with an example, so let's pull that up. So in this example we have here, we have the React DOM.render method. So this will generally occur in your application when we're creating from scratch. It'll automatically be created by the Create React app, and it'll be created exactly once. Inside of our index.html, so I can pull up Create React app in a second too. Inside of our HTML, we have this element called root. So it has a div ID root. And on the JavaScript side, we use React DOM.render, and we're passing an element, which is technically JSX, using a standard HTML tag, h1. And we are also passing to the render method the element root. So this is going to find this element and it's going to replace its contents with this h1 hello world. That is exactly how it works in WebStorm as well. Pull that up for you. Sorry, in Create React app. So this is the app.js file in create React app, but where this React DOM happens is in the index.js. So this just renders the app element, app component, to the root element in index.html. It also does this register service where you don't have to worry about that. That's just some magic that create React app does that we'll deal with much later. So more of that for now. So if we go to the index.html, is actually inside the public folder. So app.js, index.js inside source, index.html is in the public folder. We go into there, we see some HTML, and then we see our div ID root. So in this HTML file, by the way, you can modify this title, and you can modify the fave icon here as well. So whenever you see a lowercase index.js inside of a folder, that's the default file that will be loaded when you reference the folder. So it's usually the starting point for a folder. All right, so again, there's this root element here, and then index.js, which is being run in React, renders a component or an element to that HTML element. Every element that is created with JSX or using React to create element is immutable, which means it cannot be changed. So the way you actually have to make it change is kind of like frames in a movie where, you know, each frame shows some kind of incremental change, and altogether it looks like a smooth updating animation, but every frame is its own snapshot of the action. So with each change, the whole UI tree must be changed. But React doesn't just modify the HTML directly. What it does is it creates what's called the virtual DOM, which is basically like the document object model that HTML uses, but it's all in JavaScript, it's all in memory, and it's just JavaScript objects. So React uses this virtual DOM to compare it with the previous virtual DOM that was rendered to the screen, and it only applies the changes that are necessary. So it figures out all that magic for you. It's basically like compressing your animating movie, and this is great because it makes React more performant on mobile browsers, especially like the browsers that don't have enough power to keep on re-rendering the screen. And you'll find that in a lot of web frameworks. There could be problems with performance, especially on mobile, especially when you're touching links or trying to scroll, because mobile browsers are not as powerful, and these frameworks were built with a desktop in mind, and having all that power to just throw out everything and then re-render everything. So React does a good job with optimizing that. So when we're working with components in the beginning, we're going to be working with stateless components. Now, components can have state, where it means they have memory of, they can be holding values that are associated with the component, or components can be stateless, which means all their values are coming from their parent. So the parent can give component data via this props property. So props is short for properties. And when you're using stateless components, React has this kind of special component called the functional component. All it is a function, JavaScript function, that takes one argument. It's just a props argument, and it just has to return a React element. So you could return JSX directly from it. This makes it super clean. It gets all of the class structure out of the way. We don't have to worry about anything but a function that takes a value and returns another value. So let's look at this demo of stateless components and how they can be extracted further. Okay, so in this React project, let's first look down here. So we have React DOM.render. We're going to render our app to document.getElement by ID root. So we look at HTML, we see all we have here is the div ID root. So let's find our app component. So here it is. So our app component is just a function that returns. It's not taking any props. We're not passing in any props. We could pass it a prop from here. But all it does is return this JSX here. This JSX has 4 profile components inside of it. So notice with components, we're starting them with capital letters. So even though these are just functions in JavaScript, we're going to be starting with the capital letters because components should start with a capital letter. And this is to distinguish it from the built-in HTML tags. So you see the built-in HTML tags of div, all lowercase, but our components should all start with the uppercase letter. Now we're passing 2 properties to this profile component. We're passing it a name, and we're surrounding it by a string value, and we're passing an avatar URL, which is just a link to an image. And these are just images I found on Google searching for stock photos. So let's look at our profile component. So that's actually up here. So our profile component is another stateless component, so we don't need to have the whole class structure that we'll be talking about in a second. All we have is the function, a component name, and then a parameter in here to accept the properties. So properties will all come in one object, and the convention is to call this object props. All right, so all this profile component, functional component is doing is returning this JSX, which embeds the props avatar URL and the props name into an image, and it embeds the props name into a display right here. Now all the styling is handled by CSS, which you can click on and you can explore and you can mess with. But we're not going to get into that right now. So down here in CodePen, we can see the results of the rendering. So we could even change some values here, or maybe it's Sarah with an H, and CodePen will update it down here. Now, that wasn't a change through React re-rendering to the screen. It was just CodePen.io rerunning our code. All the code we have here is static and stateless. So let's see, this code up here is getting kind of complicated, and we could break it up even further. So if we wanted to extract a component from this component here, we could extract, for example, this avatar image. It's kind of funky because it requires this wrapper tag, span class name avatar, surrounding an image tag. This is in order to get that nice shadow effect and to do some specific sizing and alignment with these photos. That's why the wrapper is required. So maybe we want to use this avatar somewhere else or make it more powerful later. So we're going to go ahead and create an avatar component. So all we're going to do is name our function, our functional component, start with uppercase letter, and we're going to accept props. I'm going to go ahead and copy this out. We can pretty it up a little bit. Remember, when we're working with multiple lines, this is down here, but we should be surrounding it with parentheses. If we don't do that, some browsers may break our JSX. Well, I think technically it'll still work, but good practice to use those parentheses just in case it's really not the browser that'll break. It's really your IDE that might add semicolons when you try to format the code. Okay, so we have our props. Now we're going to change this a little bit. We're going to, well, this is fine. We'll leave it as avatar URL and name. So those are the props we're looking for when the component's being called. Now we're going to create an avatar component. We're going to pass it an avatar URL. We're going to embed the props value that we received from the profile directly into here. And we're going to set the alt text as well. The alt text is what shows up when the image can't be found. And it also helps out with screen readers. So if, for instance, if someone is blind, they may have a screen reader that will be able to tell them what the image is based on this alt text. So this is an accessibility thing that you should practice. So whenever you have an image, you should always have the alt. Now you can see we have two images. Let's just delete this second. All right, back to one. So now we have the avatar. You know, we can use that independently if we wanted to change, for instance, to just be an avatar. Accepts the same properties. So now we have two components, or really three components, including the app component. But this component basically extracted away the complicated code that was here and put it into this one component. So that's one way you can build these components. You can first build a bigger component, and then once it starts getting too involved, too complicated, you break it up into smaller components. So your to-do for this section, you should study rendering from the official doc. It's a pretty short document. But here you can see what I was talking about with it only makes updates what's necessary. So you can verify this example, but basically they have a clock on their screen, and that does a tick to update every second. Rather than re-rendering the entire page, it is literally just rendering the clock here. So you can explore that more. Another thing to do is read this components and props section from the official docs as well. So here they'll show you the class way to define a component. And we're going to be getting to that when we get to stateful components. Right now we're just doing stateless components, so we're working with just the pure functional ones. And that's just for clarity, to get you off the ground faster, and because the functional components are actually pretty cool, in my opinion. So the stateful components, we'll be using ES6 classes. Remember, ES6 is one of the latest versions of JavaScript. It's also called ES 2015. If you see that, ES6 and ES 2015 are pretty much interchangeable. So see, if we had a class, we'd have basically a couple more lines of code in order to declare the class, have it extend React component, and then we'd have to create a render method and do our rendering inside of there. Again, to actually use the component, then you can use JSX to have the component name and then pass it any properties, just like you would HTML attributes. So down here in this section, I'll talk about extracting components, and it's basically a more extreme example of what I was just doing, where it'll break down this big comment component into reusable parts. So it'll pull out an avatar, it'll pull out user info, and you can actually see the example on CodePen itself. So another important note: the properties you're passing in should be read-only. So you should not be editing the properties that are being passed from your parent into the component. So this is a method to give you really cleaner separation of code and make your components more modular. If you have code, if you have components that are modifying the properties, then or if they could modify the properties, I don't think you actually can in React. I think it won't affect much. But if you did, and actually change the values on the parent, then you could lead to unpredictable or hard to predict behavior when you try to use those properties later. So keep them read-only. Last thing you should do, I had a tutorial on last class for React. You should finish this tutorial if you can. And this will just walk through creating components on a tic-tac-toe board. Anyone have any questions about React components? All right, let's keep on prattling on about React components. So if you're still struggling with JavaScript, there are more guides for you. And as you see from this class, we had the big intro sections last class for the last 3 classes, where I'm giving you a ton of reading to do. There's a whirlwind of information. That's all to get you a base layer. But as we go along, I'm going to be digging deeper into each piece. So we went broad, and then we're going to go deep onto each of these sections. Now, if we check out this guide here, this is a pretty good guide here. It also tells you some little quirks about JavaScript. So adding 0.1 plus 0.2 ends up equaling 0.30004. There are ways around that, maybe. You can use parseInt to cut off, well, let's see. What's the way around that in JavaScript? So to get around that in JavaScript, I'm not really sure right now. We can look it up. JavaScript inaccurate math. Thanks, Google Complete. So I guess this is too fixed, but does not round in IE. So this is a common problem in web development. Is it'll work everywhere except Internet Explorer, and those are usually the more demanding users as well. Like, why doesn't it work in Internet Explorer? Well, it's because you're using Internet Explorer. You should use a different browser. Is what you'd like to say, but you can't. You have to say, all right, I'll go fix it, and then you end up bloating your code out in order to support Internet Explorer. Basically, they're just saying to use round, which is not a great solution. So there are problems with JavaScript, especially when it comes to math for floating point numbers. So when we get to state and lifecycle, this will be in components as well, but it's going to be later on. If you want to jump ahead, you can feel free to check out this state and lifecycle section. You can check out the ticking clock from the previous sections. Where is this? Rendering elements. So in rendering elements, they'll talk about this ticking clock. And this one just creates a element as a variable here. So there's a const element equals, and then it has some JSX in parentheses. It just says hello world, and then the current time. Then it's doing this set interval tick 1000. So what set interval does is it basically calls this function you pass in the first parameter every certain millisecond. So 1000 milliseconds equals 1 second. So every second it's calling this function over and over again. So it's creating the element with the current time, and then it's rendering that element to the root element. So let's check it out in CodeBin. Why not? Here we see that's all it's doing. Now if we do what it was suggesting and check out the actual source, we can pull up these elements. We can inspect this specific element here. And we see here, when this flashes, that is the change that is happening in the page. So all that's happening is this text here is updating. So nothing else is changing. Even though we're calling tick every second, and we're recreating the whole tree. We have this H1 hello world being recreated, H2 with the local time being recreated. Even with this it is being recreated. But when we go to render it, React's virtual DOM compares with the previous virtual DOM to determine exactly what needs to be changed. So it's just this string here, just this embedded value for the time. Even though the AM and the 8 and the 29 aren't changing, they're also getting updated. It's really the smallest component it can update is within these curly braces, the embedded JavaScript. All right, so let's jump back out of components. And let's talk about layouts. So layouts are generally handled in CSS, and they have to do with the whole layout for the screen, or they could be layouts for individual components. So they have to do with how you space your page, how you get elements to fill the page, how the elements are weighted, especially on, we have to worry about these days how your page looks on a mobile browser or small browser or on very, very large screens. So there are various techniques for creating a layout for your page. So like to have a header, the main body, maybe a left side navigation and a right side filled with ads, and then to have a footer at the bottom. One of the older techniques that was used, still used sometimes today, but it's really terrible, is to use the table HTML element. Now, I dislike the table HTML element so much that that I'm not even teaching it in this class, really. So this is probably the most I'll say about table, is to not use it. Don't use table, especially for layouts. You can use it potentially for displaying data, but there's other ways to display data too. You don't need to use table. It's something that's been there since the beginning, and it has all kinds of quirks across all the browsers, because every browser had a different idea of what table meant back in the 90s, and now it's just a beaten battlefield that is just broken everywhere. So table is terrible for layouts, so don't use it for layouts. It seems like it's attractive at first because it stretches and the cells stretch and all this, but no, don't use it. Do not use it. It looks terrible on mobile browsers. You can't create a flexible layout. It's just no. Another technique is to use absolute positioning, where you actually specify the exact pixel that every element on your page should be. This is also not using the power of HTML. It's very fragile because it depends on the exact screen you're looking at where those pixels line up. So it's very fragile. It does not adjust to screen sizes. And it's also tough because, well, if you wanted to adjust the screen size, you sort of could by using a couple of tricks, but then it's going to get really hard to manage all the different screens, and it's impossible to predict, how big and small screens are ultimately going to be. Another technique is using float. Now with float, you can specify things should either float to the left or float to the right. So when it use a layout with float, the elements will pretty much be pulled out of the DOM rendering, and then moved all the way over to the left or all the way over to the right, and then they can stack up in that left and right space. And it's tricky conceptually to explain, and it's tricky to use as well, because there's quirks with this as well. So when you use float, you can have elements floating to the left and right, and then after when you want to reset to go back to the center, pretty much, you have to do a float none element and basically clear out the previous floats. So it's not very modular, because you need to have that extra element to clear out. It has to have knowledge that there were floats above it, and you'll see something called a clear fix that people use to clear out the float. And the clear fix is just a class that just says, float none, no more float. So float having these side effects makes it annoying to work with, but it is necessary for Internet Explorer support, of course. IE10 does not support the CSS3 element or CSS3 property we're about to talk about. But I have somewhat of a disdain for Internet Explorer, so if you want to learn how to do float with IE10, you can just tell whoever's complaining about the layouts in IE10 to just upgrade their browser. I mean, IE11's out, so come on, at least do that. Or you could spend a lot of time getting the floats right. So CSS3, the current way to do it is with Flexbox, and it's clean and clear. It's good for small components. It works on the general page layout, although Grid is supposed to replace Flexbox for the general page layouts. But Grid doesn't exist yet. It doesn't have wide support at all. Flexbox has been around for a few years now, so it has cross-browser support, at least for IE11 Plus, and then all the other same browsers. So look out for Grid in the next few years, but it's still being formulated how it's actually going to work. But ultimately, it's going to have what tables seems to promise, but in a better fashion, a better, more standard fashion. Flexbox. So how does Flexbox work? So in order to activate Flexbox, all you need is a CSS property, display flex, in a parent element. So the container with the children in it, the children would be the HTML elements nested within the container. They all become flex items inside of a element that has display flex. And there is a little quirk in this. In order to have Safari support, especially on mobile devices, you can't just have display flex. You need to have display WebKit flex as well, with these hyphens. That's about the extent of the annoyance with Flexbox. I mean, you have to use these WebKit properties a couple more places, but it's just for Safari support. If you're not using Safari, you don't have to use it for this class, but it's good practice to use display WebKit flex. The way Flexbox works is it pretty much aligns all the children elements depending on the properties you set with the parent element. So in the parent element, you can say you want to lay out all the children in a row or as a column. Now, row means that if you have 3 elements, they're going to be in a horizontal alignment. So 1 would be on the left, 2 would be in the middle, and 3 would be on the right. Now with columns, those elements would stack up. So 1 would be on top, 2 would be in the middle, 3 would be on the bottom. Now the flex item children, can set a specific height using the height property on CSS, or you can use something like flex grow, which will automatically stretch the child to fill whatever remaining space there is. So be it a row or column, it'll go either horizontal or vertical. This value after the flex grow is a weight. So that means if there are 3 elements, 3 child flex items with flex grow properties, the amount of space divided amongst them is determined by how much weight each element has in flex grow. And this value should be between 0 and 1. So 1 means this will get it shouldn't be between 0 and 1. It can be whatever value you want, and it'll figure out how much space to apportion to that child based on its flex grow property. So when you're using Flexbox, not only can you specify things should be in a row and things should be in a column, but you can align the content as well in specific ways. So if you use in the parent element that has display flex, you can use justify content and align items. There are a few more alignment options as well, but these are the 2 you should know from the start. With justify content, you can have the best way to describe this with the image. I don't have the image up here. Let me pull it up for you. So it's visual guide to Flexbox. Is a great resource for this, and this is part of the required reading. But if we go to justify content, this is what I'm talking about with the images. So justify content has several values you can set for it. One of them is flex start, which means all the elements. So these are all the child elements, 1, 2, 3, 4, 5. The yellow element is the parent. All these elements are justified using flex start. So it's not called flex left or flex right because in other cultures, the start may be on the right side. So when you see this LTR, it's left to right context. So in America, justify content, flex start, in most Western countries will be starting on the left side and going towards the right. You also justify content, flex end, so the content will push over to the right side. You can also do a center, and you can see these Safari WebKit justify content. You can just copy all of this over. Some CSS preprocessors will do it for you automatically, but we're not using a preprocessor in our CSS yet. So when you center, all of them are pushing towards the center, and then you can use space between to spread them out, and they'll have equal spacing between them. And the first and last element are pushed over to the edge. And if you don't want the first and last element to get pushed over to the edge, you can use space around. So you can see this would be good for like image gallery or articles. You could do 2-column layout, 3-column layout, pretty easily using this kind of container. But because you can only do one direction at a time, that's what makes it difficult for bigger layouts. Bigger layouts, you have some horizontal elements and some vertical elements. Like the header would be a complete horizontally laid out screen with, you could have links in it. It could have all kinds of stuff that could be horizontally laid out, but then it needs to vertically lay out to stack on top of the body. So this brings us right over to line items. So justify content, if we're saying our flexbox is a row, then it's going to be operating basically on the x-axis. It's going to be in that row. Justify content will specify that spacing. If we did it with a column, then it would go the other way. But in the examples, we're assuming a row flex direction. Line items works in the perpendicular or crosswise axis to the flex direction. So if flex direction is row, line items operates vertically. So what does that mean? So we have a line items stretch. So this value will stretch the element so the top and bottom match the top and bottom of the flex parent. Another option is to use flex start. So these elements are pushed to the top of the parent, even though the parent has space down here. You're not centering it or anything. It's just pushing it to the top vertically. So this is a flex direction row, but we're adjusting vertical alignment. Flex end pushes it to the bottom. Center, put in the center. Baseline, we'll do it based on the text baseline inside of the child elements. So you can read more details about baselines and calculate here. We're not really going to use baseline, so that's optional. It's good to know, but not necessarily required. So measurement units. So when we're positioning elements in CSS, I talk about absolute positioning. Pull it up. Talk about absolute positioning. But what you should be using in CSS is relative positioning. So let's talk about some of the rules about CSS units and they can be used: width, height, margin, padding, font size. Anytime you have a measurement, you're going to be using one of these units. You can see the browser support here. You can see relative lengths versus absolute lengths. So let's check out these absolute lengths briefly, and we'll jump into relative lengths. So absolute lengths are, you can specify specific pixels, font points, picas, inches, millimeters, centimeters. These are not good for screen layouts because, every screen has a different interpretation of how these units should be rendered to the screen. In some cases, for example, retina displays, each pixel on a retina display is basically at a 4:1 ratio. It's 2:1 or 4:1. At any rate, the pixels get smushed together. So your screen could look very small or improperly aligned on a Retina screen. There are ways to, manipulate that using some other settings, but just avoid these unless you're doing something like a PDF generation or something like that, where you're actually going to be able to know the exact size of the the viewing area or the printing area, and you can exactly align elements. But for adjustable screen size, you're going to want to use relative length. I recommend using REM. I always forget to use REM and drop back to EM. It is relative to the font size. So it gives a good effect, especially when people increase font size on through your browser. It'll adjust all elements, so it all will look like you meant to have work that way. Another good one to use is view width, VW, and this is the width of the viewport. So the viewport is basically the screen size. We'll dig more into that later when we get to responsive web. VH, which is the height, is a percentage. So 100 VH would be the full height of the viewport. There's percent down here, which I don't know why I don't have a description here, but it's the percent of the size of the parent element. So if you're in the root and you have 100%, then it will fill the whole browser window. But if you're in a child that has a parent that has a height of 100 pixels or something like that, that child with 100% would only be 100 pixels tall. So percent just depends on the context you're in. There's also this calc function that we'll run into in this demo we're going to do in a minute. This calc function allows you to mix those relative and absolute values together to create a new value. And this is a pretty powerful function that has good browser support. Even IE9 supports it. So if IE9 supports it, then you're golden. You can use it wherever. I'll have an example of how this can be used in a second. So box model in CSS, these are all properties you can set on our content. So we can set a margin, a border, padding, and then we can have our content inside of here. So this is to space out your elements. So not only can you use Flexbox to align them correctly, but then you use padding and margins, and you could possibly use borders to affect the spacing of that individual piece of content. And that'll be mostly just learning these properties: height, width, padding, margin, border, and then in the do we have some reading for that. So let's do a demo. So we're going to go over a little bit over the 20 minutes here, but that's what the demo is for. All right, so I've prepared a little HTML document. Pull it up. See if I can increase this font size. I'm wasting time with this, so let's keep going. I can't find the font size and crazy here. It might be in review. Tab size. Okay, we'll just work with this. All right, so I have a simple HTML document. So if you look here, doc type HTML, that activates the HTML5, and then I have the HTML root element. I have a head that just links to a style sheet that we'll look at in a second. That's where the actual layout is going to be. In this body, we have the header, which is HTML5 element. We have navigation, which is just a few links in here, 3 links, just listed straight out. Then we have this main content area, another HTML5 element, with 2 articles. And this article just has what it's called bacon ipsum. And it just puts random words in here to make it look like a paragraph so you can see how your document would look with text. And at the very end, after the footer, we have, or after the main section, we have a footer, and then we end the body in HTML. That's all there is. There's just, header, nav, main with 2 articles, and a footer. As you can see, there's no types of styling on here. So if we actually take this out, save it, open this file, I'm just going to open it directly from my file browser. This is what it would look like without any styling whatsoever. It has that header, it has those links, and it has these articles one after another. And then the footer says, thanks for visiting. There's no actual style applied when you use these HTML5 elements. We have to style these out. Let's look how that's done with our with Flexbox. So one way we would do this, let's say we want a huge header. So the very first thing we should do is we should set the body margin and padding to 0. This will push this over to the edge of the screen and the top of the screen. By default, every browser has some kind of positioning it does for its content. We need to override that. And there are some there's some CSS you can use to automatically override all that stuff. We'll get to that later. Just like it's called basically reset CSS. So the body, we're going to make our flex container. So everything inside the body is going to be a flex item. You don't have to work it this way, especially in React. We're not going to actually have the flex, or we're not actually going to be manipulating the body in React. So making it another container in React would be good as well. It doesn't have to be the body. But the point is, the flex container has display flex. It also has display WebKit flex. Although I'm just using WebKit flex, I'm not using any other Safari specific properties. So it's not actually going to work in Safari this time. And the body using flex direction columns. So that means the elements are going to be stacked vertically. The header. Let's load this sample up with what we have here so you can see what the final product is going to look like as well. Push this over here. And we can just work through it actually as a comment basis. So I just commented out all this extra stuff down here. So now we just have the body, set the margin and padding to 0 so it goes to the edge, and then we're using Flexbox column, which didn't change anything because these things are already being laid out from top to bottom. So now our header is going to have a flex direction column. It's going to have a height where 100% of a viewport is 100 VH, but then minus 5 EM. This is to show the nav section in addition to the header section. So we can do the nav as well here too. I have background color set on these just to see how they lay out. But But the important thing is just flex direction, and then this height is calculated to be 100% of viewport, but then minus 5 EM to accommodate the nav header. To save that, and we'll reload here. And now we have a green header, and we have links down here. You notice these links are all mushed together. We're going to separate those links by using this margin property. And we got save and refresh, and we see the links are now separated. This header, you could have a background image in here for your course project. Right now I just have the background color set. And I use justify content and text align to push the header text to the middle. Now if we go underneath our header and nav, we still have unformatted page down here. Main section is going to grow with the available space. And then each article will have a border around it so you can see where they're laid out. So here. Main section is going to have a flex direction of row. So we're going to have a 2-column layout here. It's going to, so not only is it a flex item, a child, is also a parent. It's specifying flex information for the child item, which are going to be the articles inside the main element. So they line items, still stretch them, it'll center the elements on the row, and the main section will also have padding of 1 EM, which is equal to the font height. So each article is going to have a solid black border, and they're going to be spaced apart using the margin 1 EM. And then inside the border, it's going to use a half a EM to space it away from the border. Now we have 2 columns, but our footer is still just thanks for visiting down here. We're going to go ahead and set the background color of the footer to gray. We're going to explicitly set the height to 5 EM. And then have this align self method or property. The align self pretty much only affects this one child item to have a different alignment than its siblings. It's on that the required reading. You can check it out. And it's very useful for things like footers. So now we have this footer all the way at the bottom. Thanks for visiting. And we have our full page. So now we have this hero header that automatically adjusts to whatever browser size we're using. And then when we scroll past it, then we get our content and our footer, which also moves around based on the browser size. So ideally, if we were working on a responsive website, these columns would be this 2-column system would sit on top of each other as we scrolled like this. So on a mobile browser, it would still render to an appropriate viewing of the content. So here to do, you can do this tutorial, learnlayout.com. It's going to actually walk you through how to do layouts with float first. So it's very useful, but not necessary completely for this class, but in the real world it's going to be necessary. Study CSS Flexbox. This visual guide is great, but it's more like a reference. Dive 3 School is a more gentle intro to it. And in the course long project, you'll be creating the hero, header, and navigation sections. So here are some hints to help you along there. You can add the display flex property to the parent element and set the flex direction of the column so you can stack the hero header and nav. Then you can use the flex grow property on the hero header to make it automatically adjust. Or you can use the the height calc that I showed in that demo, and then you can set the height on the nav element to a specific value. They're like 6 EM, 5 EM. It's a pretty good height. So let me know if you have any questions on that. We're going to keep on moving forward because I burned those 10 minutes with the demo. All right, let's talk about coding style, or what a violent psychopath would murder you for not doing correctly. Based on the quote from the beginning, I'm saying anyone's going to murder anyone. Okay, so coding style. Coding style is basically the conventions for spacing and naming in across programming. Every language has a coding style, including HTML, CSS, and JavaScript. And every individual you talk to will have a different opinion on how that style should look. The main thing you should focus on is being consistent. So even if your style is wrong, if you're at least consistently wrong, then it'll be easier to follow once whoever's reading your code learns your style. So the maddening thing is when the style is just all sloppy, everything's spaced in crazy ways, and the naming, it could every variable could be named with like all uppercase letters, and then some of them could be lowercase letters, and then some of them can use underscores to separate words. But we're going to go over how everything should be spaced and named in HTML, CSS, and JavaScript, and React. React has its own rules too, so we'll dig into it a tiny bit, and we'll get more into them later. So computers don't care about your style. There are some quirks with JavaScript if you try to do a little bit of an esoteric style, but for the most part, whatever spacing you have, computers will just ignore. But your fellow humans will appreciate it if you give them a good style to work with, a good well-styled code. Not only that, it has like a psychological effect. If your code is very aligned and styled perfectly, they're like, oh, this is good code. Even if it's full of bugs, humans don't care. Computers care about the bugs. Humans that are fellow developers would rather be able to like read your code than have it work perfectly and for it to be unreadable. So always favor readability. So there are a lot of evolutions of rules and differing rules, but there are somewhat a common base set of rules we can work with. So start and end tags. So these would be like let's pull up an HTML document. Here we go, our sample. So start and end tags, so like head and /head, your start and end tags, should be on their own line. So you see we have head on its own line and the end tag /head on its own line as well. They should also be aligned with each other. So we see head starts on this character and line starts on this. So it is really it's tabbed once. There's a debate between tabs and spaces. Should you use 2 spaces? Should you use a tab? Whatever you do, just be consistent. It's everyone's gonna have a different opinion on this. I even project to project, I'll be like, all right, I'm gonna do spaces for this project, and the next project I'll be like, I'm gonna do tabs. I'm gonna try tabs. So this one in particular, I'm using tabs, just because it's a straight text file, using TextMate. Every child element is indented one level more than its parent. So let's see how this is. So HTML element is the root element inside of our HTML file. So it lines up exactly with the left edge. So that's in column 0. Now our head element is the first child element inside of HTML. This is indented one more level than its parent. So head is indented once. Now link is child to the head. So it is indented one more level than the head element. Two more levels than the root HTML element. This is a way you can clearly see the relationships between, link and head. Link is contained within head, and it's clearer because of this indentation. If we didn't have the indentation, head, link, and body all look to be on the same level. And even worse, if you did something like this, it becomes very difficult to read. It looks like you're resetting the head or resetting the root element here. So to make it super readable, just indent one more level for each child element. So it can go even deeper. You see this body, nav, A, and then is HTML, body, main, article, P, and this P is indented. Now the paragraphs, you could, ideally, I guess you would do it like this. So don't have these set up exactly right. All this extra white space will be removed when it's rendered to the browser. But with paragraph elements, there's tags. I don't really care about those tags. So as long as this one's indented, it's whatever. You could do that too, but it looks kind of funky to me. That's a little variant on the rule that I do. I just put the P tags in line with the text. Another important note, tag names are lowercase. So you see these main, article, P, nav, header, HTML, all of these are lowercase. Technically, they could be uppercase. But for style-wise, just make them all lowercase. And this is good for JSX as well, because in JSX, it's expecting your HTML tags to be lowercase, and then your components to have an uppercase letter. So it's good practice to use all lowercase tag names. CSS common rules. So here's another file we can pull up. So this is how a CSS file should look. It should have the class names or the selectors. So these are all selectors. These are using tag names. But we could have a class name like something like that, dot, whatever text, that would be a class name. From your CSS reading. All the main properties, or all the main selectors and class names should be on the left edge, just like a root element. And then anything inside the curly braces, the properties, should be indented one level. So exactly one level. So either, if you're using spacing, the 2 spaces or the 4 spaces, they should all align perfectly. If you're using a tab, it's just one tab character. The closing brace should be on its own line. So technically you could have something like this, but that makes it unclear that this body element ended, and all of a sudden you're starting this one. And then what's even worse, if you try to cram this all in here, Like, oh, I'm saving characters by doing it this way, but it just becomes difficult to see when one property ends and the other begins. So this should be on its own line. Every property should be on its own line. And they should be indented one level for clarity. Now with CSS, you can't nest properties or anything like that, so there's no multiple indentation. But if you use something like what's called SAS, SCSS, or SASS, or less, which are both CSS basically enhancements, those particular preprocessors can have nested elements. But in this class, we're going to be doing all vanilla CSS. So we're going to be using straight CSS. So the you only have one level of indentation. Another thing to note for class names, they should be all lowercase. So if we had a class name in here, say let's add one. And then words should be separated by a hyphen in CSS. That's opposed to doing something like using camel case in CSS is not advised. Use a hyphen. That's the convention that people have been following, and now it's really caught on. You know, we could have a font size in here or something, make it slightly bigger or something. You should also have a space between the colon and the value, although that's a value, or that's a rule that I often violate, as you see here. It's not it's not going to affect the readability as much as the indentation and then the naming. So with class names, always lowercase, separate with hyphen. So like body copy. And class names should always start with a dot, and that's just a CSS rule. JavaScript. So now we're getting a little more complicated. So JavaScript has more functionality and complexity. So there's a lot more that could look ugly. So the JavaScript common rules, these are going to vary wildly or widely depending on what company you're working for or who you're talking to. But these are the common rules you should follow in this class that also comply with React's rules. So first thing, we just talked about in CSS, you should use hyphens to separate words. But in JavaScript, you should actually use camel case. So that means you should start with a lowercase letter, you know, like this lowercase c, and then every subsequent word should have start with an uppercase letter. So you see camel case as a variable name would look like lowercase c, camel, uppercase C, case. So this is just for functions and variables. But with class names, they should use what's known as Pascal case, where the first letter is uppercase and then each word is capitalized after that. So, for example, would look like something like class name. This is a convention to follow that will make it clearer when you're using a class versus a function or variable. And it was very necessary in versions of or JavaScript ES5 and lower, where you didn't actually have this class keyword. yeah, your functions basically acted as classes, and that's the old way to do JavaScript classes, is to use just a straight function. But to separate your class functions from other functions, you would just use this convention of having this uppercase letter starting for the function name. So at most you should have one statement per line. So a statement is an executable piece of code. Let me pull up JavaScript file to be referring to here. A better one here. Okay. So just have one statement per line. It says an export default app. Each of these import statements are one per line. I just mushed them together by accident. There we go. Control Z, Command Z, your friend. That's undo. And now. And every statement should end in a semicolon. So this render function, functions do not have to end in a semicolon as function declaration, but this return statement inside of here is the whole return statement. It ends in a semicolon here. The export default app ends in a semicolon here. It is possible in JavaScript to just get rid of all the semicolons, and some people I've worked with completely prefer this because I think it looks cleaner. But without the semicolons, there is some quirky behavior that you may run into that will cause bugs that you didn't even think could happen because of the way JavaScript figures out, when a statement ends. The way it assumes when a statement ends, it's based on what the next line's characters start with. To just clarify all that, just use semicolons. There are some languages with better rules that don't use semicolons, but use semicolons in JavaScript. Keep in mind JavaScript was initially created in 10 days, and it's just been adding to that 10-day project since then. Use comments. I don't have any comments in here, but if we wanted to add a comment, we could use / to do a single line comment. And another common style thing is to put a space after the //. Or we can use / to do a multi-line comment. Generally, you can indent these parts. That looks a little cleaner. Or you can use /* to do a Java comment, and these would be used at the top of functions. You don't need to worry about those so much for this class, but if you take another programming class, it'll talk about documentation comments. Each child block indents one more level than parent. So block usually starts with this the curly braces, and then each statement inside the curly braces should be indented one level. So I'm using spacing here, so there's 2 spaces. And then inside this render block, everything in here is indented at least 2 levels now. So this render was indented 1 level, now return is indented 2 levels. And then inside this return parentheses block, technically not really a block, but still a child, all these are indented 1 level. And then this JSX uses HTML rules to indent the children 1 level as well. So you could totally, have something like this, which will compile, work fine. But when another developer sees it, they'll be like, oh no, this code is sloppy. It's probably terrible code. So So how about your fellow developers? You can make them think your code's good by just keeping it nice and clean. So React, I'm just going to point to the style guide and say, here's a style guide, because the things it talks about are a little bit more complex than we need to right now. It talks about the ordering of properties inside of component. We'll talk about these as we go. We'll talk about these when we get to stateful components. And it talks about how you can format JSX. It talks about type checking. It talks about some kind of not only styles, but conventions you can follow inside of React. But if you follow the JSX or the JavaScript rules, you'll be well on your way to do those. So if you're using WebStorm, you don't really have to worry about these style rules explicitly, because WebStorm does a pretty good job with auto formatting. And the way you can get to auto format is you can go to code and then reformat code. And you see over here there's a shortcut you can press, which you should learn depending on your system. On the Mac it's Option Command L, but on the Windows it's Control Alt L. So click that. It'll fix up my disgusting child element being on the left side while you're coding. So I could be coding, I could have stuff like this and like that, and like, oh, I can't have error in it. That's not going to work. I have some disgusting spacing here, multi-line comment, even fix this. I think if I have no space here, it might fix it. I could have my imports on the same line. Okay, so now I kind of messed it up. So now I'm going to press Command Alt L. And that's what it fixed. So it didn't touch my JSX, unfortunately, the spacing. Which is a good and bad thing. But I think there's some options you can put in there to override that behavior. And that would be in your preferences in WebStorm. But the default ones work great. As long as you have the default auto format, you can do great. There are some packages, something called Prettier, that'll do this for you automatically. But it's kind of dangerous to just have it automatic. So just using Command Alt L or Control Alt L will give you a good style for your JavaScript. And it works on HTML too. So if we go into HTML, we can Command Alt L all this, and it will fix it. Looks like it's not putting the child elements over indenting the child elements, but it looks okay. This is fine. So your to-do for this section: study the HTML and CSS style guidelines, writing your best code. This is a good combined HTML and CSS style guide. Read through that, and we'll talk about bad code versus good code. Talk about all the indentations, and then a JavaScript style guideline. A good one for that is the W3 schools. And this is what we'll be following. This is one of the less complicated style guides for JavaScript. You can look at the Google JavaScript style guidelines. You can look at Facebook's style guidelines, and you can actually check your code. You can set up error checkers in your code to determine if they're following Google or Facebook style guidelines, along with a lot of other companies. But just following these style guides in the W3 schools, it's a great start. It'll make people happy. It's good enough. It's great. All right. Any questions? Let me know. We'll be recording next Monday. I hope you all have a good weekend and work on your projects. Let me know if you have any questions with how that should work. I'm hidden. But otherwise, I'll see you, or I'll talk to you guys next class. See you later.